So this week I gave myself a challenge of building an offline first iOS app where I'm actually hosting a small language model entirely on my iPhone. So I've got an iPhone 12, and so the goal for me was to understand how do I actually host a small language model on an extremely resource constrained device and actually do it in a way where it actually works and the app is useful and I don't have to pay any cloud API cost to Anthropic or OpenAI. And so I want to walk through some of the lessons that I learned. I learned three really big lessons actually, trying to get this app to actually work and actually be useful for me. And I want to walk through it so that hopefully you guys don't have to make the exact same mistakes I do as you think about maybe hosting models locally or building apps based on local models. Now, a bit of background on me. My name is Sanjay. I've been in tech for 8 years, primarily on the go-to-market side. My expertise really lies in two buckets. The first one is getting companies that have never heard of my product or service to become customers for the first time. And the second one is working with existing customers, building new relationships and programs so they not only use my software and renew, but also expand it across different teams and ultimately drive way more revenue for my company. So I'm primarily on the go-to-market side, but the reason I wanted to take on this project is about a year ago, I got very deep into AI engineering and really wanted to upskill myself on how to actually build applications using these really powerful AI models. I've been using ChatGPT, Claude, Gemini as productivity tools for the past, basically since the inception of ChatGPT, but I haven't really learned how to, use the models themselves to build applications or agents. So last year, I started going into a journey of learning how to do programming, how to actually call APIs, how to manipulate data, and then about Christmas time of 2025, then I started learning how to build agentic systems, how to build some basic chatbots, things like that. So this was my first real attempt at understanding how do I build a full application where it's very resource constrained, where I have to learn how to host a small language model from Hugging Face onto a device like an iPhone, and how do I actually make an app that's useful for me. So anyway, without further ado, let's actually dive into some of the tech decisions I made and some of the lessons that I learned throughout this process. The first thing I want to share is the actual constraints that I had to deal with going through this project. The most critical constraint is I've got an iPhone 12 Pro Max. So for anyone that knows, this is like a pre-ChatGPT phone. So this iPhone only has 6 gigabytes of RAM. So, and also iOS takes 2 gigabytes of it. And so that reserves 2. So you only really have about 4 gigabytes of RAM that's actually usable by your apps. And so I had to figure out what was a model that I could host on my iPhone that had enough headroom so that inference wouldn't be a total nightmare. Because I wanted a model that was smart, but I also didn't want a model that would take 30 minutes to give me an output. So ultimately, based on doing some research, chatting and using ChatGPT and Claude, I ultimately landed on the Qwen 3 1.7b model. This is an 8-bit quantized model. It comes out at 1.8 gigabytes. So it's a little tight, but there is a little bit of headroom. So the inference performance is not terrible. It doesn't take minutes for it to respond. But ultimately, this does actually fit on my iPhone. It's on my iPhone today, and it cost me $0 to run this, right? So I thought this was a very cool thing that I wanted to highlight on the fact that, yeah, there are models out there that you can actually put on your iPhone that actually work while you're using other apps in the background. Okay, so the first thing I learned was just good memory management in an extremely resource contentious environment like an iPhone. So if you guys see right here, there's the Qwen 3 1.7b model. As I mentioned before, it's 1.8 gigabytes, right? So what happens is without proper memory management, a user will go to the App Store, download this app, and when they download the app, the Qwen model will actually be bundled into it. So they're downloading the 1.8 gigabyte model onto their iPhone itself. Now, the interesting part is Apple has very strict guidelines on how much memory a single app can take at a given time. And so without good memory management, what ends up happening is the user will download the app, and the first time they click on it, that entire Qwen model is going to get loaded into memory, all 1.8 gigs. And that's going to flag Apple as a memory warning, especially if the user has any other apps in their background, which, if anyone is using an iPhone, you probably have 10 apps open right now that are all sitting in the background. So then Apple is actually going to kill the app. So the user won't even be able to load up the app and boot it up and use it for the first time. So in order to get around this, there's a couple things you have to do, or a couple things that I learned at least. Maybe there's better ways to do it, but this is what I learned through my research. First, let me move this out of the way. First, you have to go into Xcode and actually increase the memory limit so that you can actually download the app and actually build it and build it into the App Store. I had to do this first because I needed to first check that I could even get a model onto my iPhone. So first thing I had to do was increase the memory limit. The second thing that I had to do was also implement lazy loading of the model. What that means is whenever the user opens the application, the model doesn't actually immediately get loaded into the app as well. So it doesn't immediately go into memory. It only goes into memory when the user invokes the app itself. And so let me actually show what that looks like in practice. So let me try to move this stuff around. So if we actually come in here, so this is the app itself. I'm going to go to Xcode real quick and just rebuild this app process. And so now it's currently in the process of building the app itself. So let's give it a second. So, okay, so it just rebuilt the app. So it just rebooted the app, and the only thing that loaded was the embedding model and the vector store for the notes that are sitting in the vector store. So what we can actually do here is, let's say, we go into the future, and I say, for tomorrow, April 26th, I have a agentic workshop in downtown on building Vercel agents, and I'm going to get dinner with friends, something like that, and then I hit summarize. So look on the logs on the right side. So this is at of core right now just a basic scaffolding note, but right now is the only time the actual model is getting loaded into memory, and it just went through the process of summarizing that text, and when you hit save, it also embeds it. So that is how you can make sure that Apple doesn't automatically kill your app, is by not loading up the model in memory the second the app boots up. And what actually happens is if I come here and actually put the app in background, you actually see that the model gets unloaded from memory. So it actually frees up the memory for other applications to use. Now, this app is not like what I'm going to retire on, but I think this lesson is really important for me because a lot of companies and even myself are looking at, does it make sense to buy a GPU and host a larger model locally? And if you buy a GPU, it's really expensive. And so I think it's really important to understand how do you load and unload models so that whenever a model isn't being used, that extra GPU capacity is getting used by another process or another model. So this is really helpful for me to understand how do I load and unload models whenever they do actually become relevant to the user or the use case. The second main lesson for me was related to context engineering. This is probably where I spent the bulk of my time because I could not for the life of me make this app and model somewhat useful without having to tune just a bunch of knobs and mess with the context window and the system prompts and all that other stuff. So I actually want to walk through maybe some of the key lessons that I learned. The first one is whenever you have a small language model, the context window is so small. This one is 4,096 tokens that I initially set the context window to that. And then I built an eviction process. So basically, if we actually go into the app itself, past chats are getting stored in this context window. And I had this eviction process where, at 4,096 tokens, it kicked everything out. The app, for the life of it, would just completely hallucinate in the middle to the late parts of this. And so what I ended up realizing is actually I don't have 4,096 tokens because by the time I get to there, the app is basically useless to me. So I had to come up with another number just through a bunch of trial and error that actually made this app useful. So out of the 4,096, I actually have about 2,000 as the real number behind it, right? So the idea is that I've got about 1,400 tokens here, both for prompts and messages. And then I've got maybe 600 additional tokens that aren't visualized here for the responses from the agent itself. So the idea behind it is overall, if you're looking at everything, the app budget's about 2,000 tokens from the entire 4096. Because if I had it up to 4096, the app just doesn't work. The model just hallucinates. So that was the first thing. If you guys have any advice on how to do this in a non just bashing my head against the screen way, where I had to just keep trying and reducing the numbers and messing with it, that's ultimately how I figured it out. But anyway, this does work. The other thing is, I'm used to just using the compaction process in Claude. You actually have to set up an eviction process here. So when this does get to 1,400, these notes will get cleared from the context window to make room for the next set of messages. So that's a capability that I had to kind of learn on how does this actually work? How do you build this out? And obviously, these agentic apps are super easy to use to actually write the syntax for it. So that was one piece. The second one that I think was really interesting is this thing that I've highlighted on Xcode, which is the batch itself. So what most times that I've seen is like context window is like, this is like the max number of tokens you can have in like a single conversation with an LLM. What I didn't know about is this like batch variable. And essentially what batch is like the max number of tokens that are processed in like a single pass of a neural network. So essentially what that means is whenever you input a prompt, like let's say, so initially this was set to 512, but let's say I input a prompt that's 1,000 tokens. The LLM is actually batching those into like two sets, right? So it's taking, 1,000 divided by 512, so those are two batches, and it's having those tokens in batches of 512 pass to the neural network. For the life of me, I could not get this to work. And like how I figured out this was the issue is whenever I would like have a conversation, as the context window would fill up, I would keep like messaging it, and then all of a sudden the model would stop responding to me. So I'd ask it a question and I would have this conversation, and then it would just stop responding to me. And we had to go and like try and like, I was trying to figure out like how to root cause it. And ultimately I realized like there was like a bug or some sort of like issue here. And so I just changed this to like the max setting, and it's actually been working really well since then. But this is a variable that isn't really, from my understanding, exposed via the cloud APIs. Like Anthropic, OpenAI, they all handle it for you. But when you have to host your own models, especially at SLM, which can hallucinate very quickly if you're not careful, you actually have to be very careful on how you set some of these variables that are, kind of, you don't have to worry about if you're dealing with a cloud API. So those are some of the other things. I think another piece for me was just like the eviction process. So when this does eventually hit 1,400 tokens, these these messages, basically the user and the assistant messages will be paired together. So what that means is like when this is 1,400, this message and then this message will both go together. So these are almost like paired together. So these two will go together and these two will go together, so that there's somewhat like relevancy in the messages that are being saved in context. That's something that you have to build when you are hosting models locally. And then what else was kind of important? I think there was a third thing that I had on the top of my mind related to context. Oh, the other thing, yes, I almost forgot about this. The system prompt. So this system prompt, when I first had it, was like 2 sentences. It was like 14 tokens. It was like, be a helpful assistant and answer questions. The model hallucinated so much with like the system prompt that I spent so much time on this, because what ended up happening is like I would ask you like, oh, what's 7 plus 7? And it would say like, oh, 7 plus 7 is this grocery store, somewhere over there. Like it would completely hallucinate. So it's really important that the system prompt is grounded in whatever data that you want the model to use, especially in the smaller. So in this particular context, I said like your helpful assistant, obviously this is a pretty large like system prompt, but the idea behind it is like all of your answers should be grounded in the notes that the user is providing you. And if you don't find the answer in the notes, reply to the user that you don't know the answer and that there's no notes on the answer. And that has been a really helpful way for me to actually kind of trust the quality that is coming out of the model response. The third and final like major lesson I learned in this project was actually how to implement RAG. I actually thought RAG would be the easiest part of this project because I assumed that I would just need an embedding model and a vector store. And then, whenever I summarize these notes, they would get embedded and then my model would just quickly retrieve the information and answer. I was like, this is great. Like the model doesn't have to connect to the internet and like have all this information that it has to process. It's just like 5 notes. In practice, it was actually way more difficult than that. Primarily because of the way I designed the system actually. So initially, let me actually show you what it looked like. So I would do this. I would actually only embed the summary of the note. So a user would go in, like me, the user would go in and save and re-summarize, generate a summary. This is actually a bad example. Let's just go to like a longer note. And if you go here, like you actually lose a ton of information when you summarize a note like this. And there was no way to actually go to like the ground truth or the final notes. So I think the first issue was I embedded the wrong thing, which was the summary. And part of that, I also forgot to embed the title in the process when I first set this up. So the model never really got like, unless I called out like very specific words in the summary, it really didn't know what to respond to. That was the first issue. And also in that point, you might as well just do like full text search, right? Like why even do semantic search? So that was the first issue. The second one was more related to how I actually went about evaluating semantic search and like this RAG part of the project is, essentially I embedded a bunch of notes and we were doing like cosine matching as the, the algorithm to figure out like, is my query, relevant or similar enough to the specific embeddings. And I would, ask a question and then I would see like, okay, here are the different similarities, like here are all the vectors and here's like kind of the similarity to your user query. And I would see like, okay, like this note was like the note that I know should have been retrieved was, 0.18 similarity, and the threshold that I set was 0.25. And I was like, okay, let me just set the threshold to like 0.15. And I kept doing this. So I basically was like, just like trial and erroring. And I'd be like, okay, like the threshold just needs to go down so that like more information just gets in. What I realized what was happening is as I continued to reduce the threshold, more unrelevant information actually ended up going into the model. And the model actually started just spewing stuff that just didn't make any sense. So as I like reduced the threshold, either the model like wasn't getting the information or something was happening, and the model would take part of the information that it needed and then just come up with other stuff and then give me an answer that just like didn't make any sense, right? So it would say, like it would have like part of the notes right, and then it'd be like, yeah, you met this person at the park. And I'm like, that's just not like the correct answer. So ultimately I had to figure out like a better way to do this. And what I ended up like doing is a couple fold. Like first, instead of just embedding the title and the summary, what I actually ended up doing is chunking the full notes itself and then embedding those chunks. And that was actually much better to do matching because essentially what happens, like when the query happens, it's going and actually finding the individual chunks and then basically just like inserting the excerpt from that specific chunk or that chunk itself into the context window for the agent to reason over. And that was way better from an accuracy perspective on giving me like a proper output. So rather than just doing the summarization and embedding that whole thing, let's just take the full notes and actually just chunk them with the title and embed that. And then when you do the user prompt, it goes and identifies the right chunk and then inserts like an excerpt or the whole chunk itself. So that is how I was able to at least get better matches. The other thing that I think was really interesting is I wanted to get away from like it giving me wrong information because, when I have 5 notes, like, I mean, I can go and like read all 5 of these, right? Like that's not, but let's say I had 1,000 notes. Well, I can't go individually into 1,000 notes, especially if some of them start getting blurred together. So I had to figure out a way to make the model just tell me no. So I kind of implemented a guardrail where if there is no like information, right, there has to be like a grounding rule of like just say like nothing. So if I come to this chat window and say, what is the capital of the United States, what ends up happening is it might just say like, oh, couldn't find a retrieval note. What if I say like, what is the capital of Texas, right? It's just going to automatically just say like, hey, I couldn't find any information on this. Can you try rephrasing it with a specific note? So that's a way for me to just like ground truth everything so that I know that like at least if it doesn't know the information, it's not hallucinating and telling me something that's just incorrect. So that's the video for today. Hopefully you guys found it valuable. This has been a super fun project for me to build. I did only have to bash my head against the wall a few times. So outside that, I had a lot of fun, learned a lot. I took a ton of notes that I have in a Google Doc that I'm probably going to review over and over again, especially when it comes to context engineering specifically. But yeah, guys, I'm just kind of posting more content on how I'm using AI to grow my company, and also on the as a aside to that, how I'm building these agentic systems, learning about local LLMs, things like that. So if you guys find that stuff interesting, follow me here on YouTube. And outside that, I'll see you guys in the next video. See y'all.